Start the recording. And the recording is now in process, isn't it? Okay, it didn't give me the response that I expected, but it seems to be running. Okay, so sample output with inputs ALF. Oh, I see. Okay, so there's an initial 3 members of the dictionary, and then it's going to accept input for 1 new member of the dictionary. And so new email, which is the value, is assigned to the dictionary under this key. Okay, so now we've got to print out all of the contents of that. So for a key in contact emails, that for loop is going to enumerate over all the keys. So now we just have to format the printout. So print, and we want the email first. That's the value. No, it's the which one goes where? They want email first, and that's the value. So contact emails and use the key is key. Let's try that. Woohoo! Okay, so let's go over this. Ask me questions because dictionaries are relatively new to us. So ask me questions about this. Okay, anybody? So by silence, it could mean several things. Among them, that you don't know what to ask. Another option is dictionaries perfectly well.
In our bingo project, are we using dictionaries or nested lists or both? Like, what are we supposed to be using?
Okay, we're going to go over that today. You may have already noticed that I have extended the due date of the bingo project by another week. So instead of having been due on Monday, it'll be due next Monday. So during class today, we're going to build the board. Okay.
I have a question for 6.6 section 6.1.1 challenge activity. I mean, yeah, in right here in
6 point.
That one, yeah, 6.1. Go here,
Yep.
and then scroll down to wait. If you see the first challenge, that's 3, 2, 1, and number 1 above, not that one.
Where is it?
Scroll more.
Up?
Yep, up.
Here.
Right here, finally.
Okay.
Yeah. So it says this is a basic function call. All I put down is asterisks and stuff.
Mm-hmm.
So it wasn't exact. Now I don't directly type in asterisks. I thought it wanted me to type in like target pattern. Wait, no, that's just instructions. I guess not. Well, get pattern, print, get pattern,
Okay, so get pattern is going to return 5 asterisks. So they want it to print out. So there we go. Let's try that. Okay, so get pattern, this is, as it says, basic function call. You're just calling the function, it's returning a value, and you're printing it.
Oh, I see. I see. All right. Thank you for that.
You're welcome. Now, a less optimal way of writing this would be to say S, some variable gets the result, but then you just end up printing the result. So you see line 6 is shorter than the combination of line 4 and 5.
Yep.
Okay. Okay, other questions?
I have one more question, which is for 6.2 point. Oh, sorry, 6.1.2. Didn't mean to confuse you
Okay.
there. I almost confused you there. Sorry.
Okay.
Anyways, let me continue. Let's go on 6.2. Here we go. 6.1.2 basic function call. It says complete the function definition to return the hours given minutes. Here it gives you the output 210.0 with another sample output 3.5.
Okay. All right. So this is saying, given a number of minutes, return the number of hours. So how do you compute that?
So I give
How many
number
minutes are in an hour?
60 minutes in an
Okay.
hour and
So
return 60
return
minutes.
a rig minutes.
Original. Does that what it
Yeah.
stands for?
Yep. Divided by 60. Okay, let's try that. Okay. That's all it was. You could also have said something like, and then you could return hours if you like. There really won't be any big difference there. Maybe this makes more sense. Let's run that. Okay. One final question, if someone has it. Okay. All right. So let's do this. Hello, look in my eyes there. So in thinking about the bingo board, you want a 5x5 arrangement of something. So to start out here, we don't need that. So to start out here, the first thing you want to think about is, what are you actually trying to model? Okay, we're trying to model a bingo board. Good. What is important about a bingo board? What are the things, what aspects of a bingo board you capture? Well, the first is that it's a 5x5 arrangement of something.
Rows and columns.
Yep, rows and columns, 5x5. But of what? what data do you need to capture and model with your design of a Python bingo board? Now, there's many, many ways to design the board, but what is the essence of what you need to model? When you look at a bingo board that's in process, you've already been playing the game a little while, what is the most important two things?
You need to know like what number each of the squares has, and you have to be able to know like whether that number's been called or not.
Exactly. So you need two things. You need a value and you need a status. So has it been called? And you also need it to be 5 by 5. Okay. So I'm going to propose to build some code that is going to build a bingo board that captures this information, and this information. Okay. So how about we go here, back to my friend Shuffle. And let's make sure that we do things the right way. Def main pass, I'm going to build it incrementally. So if dunder name dunder equals dunder main dunder, call the main function of your program. Okay. So I'm going to develop this incrementally. Board is equal to create board. And then I'm going to print the board. Def create board and pass. Okay. All right. So main is going to create a board. Create board is going to do all the work necessary, and it's going to return a board object, and then we're going to print it. Okay. So now let's fill in some information about the board. So board, I'm going to say, is an empty list. Okay, for I in range 5, I'm going to say board dot append something. I'm going to append the results of create column. And then return the board. Okay, so you see how I'm breaking it down. I need a whole board, and a board is created out of 5 columns. So now let's work on the columns. Def create column. And I think I need a parameter. You know why? I'm pretty sure I do. I need a parameter here. And I need the parameter to tell me which column I'm creating. Okay. Anybody have any questions?
Okay, I'm pretty sure you already went through this, but what does if name equals main? Like I saw that in the shuffle. I still don't understand what that means.
Okay, so Python files like shuffle.py can be incorporated into other Python files. So for example, when you say import random, or when you say import shuffle from random, that's an example of having one Python file incorporate another. So this is what allows us to write code that works, whether it's standalone or incorporated into another Python program. So remember that when Python starts reading a file, if it notices a def, then it reads the code but doesn't execute it. So Python, whether or not this has been imported into another file, whether or not, so it doesn't matter, Python will read and remember, Python will read and remember, Python will read and remember, and finally we get down here to naked code. Naked code, Python, as it reads it, it executes it.
Quick
So,
question, sorry.
Yeah.
Is that what's called function calling? Is when you do main, empty slash, is that what's called calling the function?
Yes.
Okay.
That's a call to main. Here's a call to create board, and here's a call to create column.
Great. Awesome. Thank you.
Here's a definition of create column, a definition of create board, and a definition of main. Okay. So to finish the answer for Jez, what this says is it's naked code, and it says, if this Python file is the one being run, then go ahead and launch into the code. If it's not the actual Python file being run, but some other file is, main will not be called. Does that help, Jez? Good. Okay. So what is in a column? So numbers are in a column, and how many are there? Let's see. Let's make a list out of a range which begins at column number times 15, and it ends at column number +1 times 15. Okay, so let's see what this does, first of all. So I'll just print the numbers, and that's all I'm going to write. And I better return something, so I'm just going to return numbers. That's temporary code. Okay, let's try that. Okay, so check it out. The first column, the first column has 0 through 14, then 15 through 29, then 30 through 44. That looks pretty good, but I want to change one thing. I want to go back and say +1 here and +1 here. Let's try it again. Good. Now I have the right numbers for B, I, N, G, and O. So numbers is not the column. I haven't gotten there yet. Numbers includes only those numbers which are allowed to be in a specific column. So next, here, let's, I'll leave that. Next, let's shuffle numbers. And that means from random, import, shuffle. All right, so let's see how I've changed my code. Write a little, test a little. Okay, good. I still have just the right numbers in each printout, and now they're in a different order. They're shuffled order. So what I'm going to do next is grab only the first 5. All right, so let me eliminate this printout. And this is not going to be correct anymore. All right, so the column is equal to an empty dictionary. And now for the first, okay, I can do this any number of ways. I'll do it this way in range of 5. This is the simplest, most straightforward way. Let's see, do I want, okay. Nope, nope. I don't want that. I want to make this a list. But what goes inside the list? So column dot append. Here comes my dictionary, where the value is numbers sub I, and the key value maps to the number, and the key called initially will map to false. All right, now let's print column and return column. All right, let's just see what I get. All right. So here's the first one. I've got numbers 1, 5, 9, something I can't see, 14, and 13. It doesn't matter that they're not in order. Doesn't matter. It's good that they're not in order. And for every one of them, they're initialized to false. Okay, then let me eliminate this. And let me ask you, how are we doing so far?
I think I'm following it pretty well.
Good. So a board will be a list of 5 lists in which are 5 dictionaries. So board sub I specifies and it's 0, 1 species. Okay, specifies 0, 1, 2, 3, or 4 for BINGO. And then board IJ specifies 1 element of the board, which has both a value and called. Okay. Now, before I return the board, I want to do one thing, and that's mark a certain cell as having been called. That's the free spot, and it doesn't matter what its value is. So board 0, 1, 2, that's the middle. 2 called equals true. So the outer list contains an inner list, and each member of the inner list is a dictionary. Is that cool or what? Okay, so now let's return the board and print the board, and let's see what we get. Okay, so the first line goes from there to there. I mean, sorry, that's the first column. And you see they're all valid numbers for B. Here's the second column, and all the values are valid for I. Here's the third column, which I need to move this. Here's the third column, and where is my true? Where is my true? Does anybody see that?
I don't think anything was marked as true.
Oh, that's interesting. Okay, I think we've just experienced an oddity of dictionaries, that apparently you're not able to reach inside a dictionary and change one of its values. So instead,
Professor,
yeah,
I copied the code that you had, and I have a value true.
you
in the-
do.
yeah, in the third.
Yeah, I do as well.
Huh. Okay, then what have I done to earn? Oh, you know what? Maybe I should try saving the file. Yeah, okay. That's better. You see, it happens to me too, everybody. Forgot to save the file.
I saved my file and it's still nothing's being marked as true.
Okay, check it very, very closely against the code you see on screen.
Yeah.
Professor, I might have missed a moment, but do you have your def create column in a different file right now, or no?
Nope, that's right up here.
Okay, because I'm not getting any output as of now. Would you
Well,
just
I
hold your screen right there?
removed the print from here, and it's now in main. So did you do that?
Yes, I did. I should have my print in main.
Okay, so check very carefully what I have against what you have.
Oh, yep. I forgot to remove that print.
Okay. Then now for the first 5, add or append a dictionary with the value and false, with keys, value, and called. Okay, that seems like some reasonable comments for that function. Okay, now last class, we worked with a card deck. And that was very similar to setting up the bingo balls. Okay. So the specification suggests that you'll choose a ball. All right. And for each ball, apply the ball to the board, then check for a win. There. So that's an outline for Maine. Of course, you would have also okay, and then this. Okay. Now, how would you check for a win? Let's look at that. Let's break down checking for a win. And that would include for each column, check if all called. For each row, check if all called. For the diagonals, check if all called. So maybe we should have a function that says something like this: def check for win. And we send it the board. If not, it could be something like this: check columns for win. Okay, so if you didn't win by columns, then you could do if check rows for win, giving it the board. So if you didn't win that way, then check if not, check upper to lower, upper left to lower right, give it the board. If not, finally, check upper right to lower left the board, then you haven't won. Otherwise, return true, you did win. So writing a single function, check for win, would be really hard. So let's break it down into the different ways, the individual ways that you might win. And that way you're writing less code per check. And also you get to test it one at a time. Oops, return false there. Let's see, check columns for win. Okay, expected an expression. Let me change this to that. Apparently I was mixing languages. And to make it all compile, make it all work. And finally, okay, so now the Python is all correct. Okay, so this is my suggestion to you. Rather than writing a single function that checks all the different ways to win, break it down into multiple specialized functions. Sound good? Okay, so does anyone have any questions about the work that we've done today?
One question for those individual check, like for example, check columns for win. What would be the type of code that you would go in there? Would it be
Well,
like you'd put a certain something with a list, I know, but or with the list, but
here, so all 5 columns are checked in the same way, right? And that would be for column 0, row 1, row 0, row 1, row 2, row 3, row 4. Are they all called? If so, return true. Stop and return true. Otherwise, go on to column 1 for row 0, 1, 2, 3, 4, 5, and that can all be in a loop. In fact, it could be in the nested loop. So let me write it a little bit differently. For each column, for each row in the column, check to make sure called is true, right? So if you've examined the whole column, and all the cells called equals true, then winner. Okay, Sam, so that's kind of an outline. Kind of an outline.
Gotcha, gotcha.
Okay, now for rows, notice all rows are checked in the same way. That's why I broke it down this way. And then I separated out the diagonals, not only diagonals apart from rows and columns, but I separated them out from each other. So loop for 0, 0 and 1, 1, 1 and 2, 2. That one's going to be true already. And 3, 3. You see how you can do that with a single loop. And then this one's a little different. It's going to be a loop for 0, 4 to, which way am I going? From upper right. Nope. So I want to do 4, 0 to 3, 1 to 2, 2, but we know that one's a true already, to 1, 3 to 0, 4. So that checks the other diagonal. And see if you can write that in a single loop. Okay. So what I did is I really broke it down from high level to the lowest level. And also I combined the various checks that work all the same way. Okay, so I hope this gives you some insights into the bingo program. And feel free to revise any submissions you've already made if you want to. And also feel free to submit by next Monday, this coming Monday. Okay, and that will be the true deadline for the project. Okay, everybody?
All right.
Okay, is there any part of this you'd like to go over again? Happy to do so.
Can you go back down for a second, Professor? I just want to look at something on your code.
Okay, how far down?
Right there. Perfect. Thank you.
You're welcome. Okay, so the key insight that this program is affording is in the creation of the bingo board. And the secondary key insight is breaking down the bigger problem into smaller problems. That's the learning to think algorithmically. And that first key insight is you begin with what about the data that I need, is it that I need to capture? What do I need to model in order to get my algorithms to work? And the key insight there was that the individual bingo cell needs both a value and a Boolean to say whether or not it's been called. And then on top of that, we built a structure that would make it easy for us to check rows and columns. And that's list within a list. Okay. So perhaps your outer list may have been a dictionary. Maybe you created one that had B as the key, and then its value were the individual cells in the Bs. But notice how that would actually make writing the code to check for a win harder. Because with just lists, inner and outer list, we can use for loops to just, specifying the coordinates, so to speak, on the bingo card. And it makes it very easy, very straightforward. Okay, everybody. I hope this has given you some insight. And you'll create great bingo games. Now, I'll just mention, if you feel like going further, you could, don't hand it in because I'll get confused. I'm a very simple-minded old man. If you would like to go further, see if you can't write a program that'll support any number of bingo cards. And what you'll find out is that as the number of bingo cards goes up, the number of balls necessary to be called goes down. So if you have enough cards, somebody will win in 5 balls. 4 balls actually is the minimum. And if you were in a bingo game like that in real life, boy, would you be annoyed. Somebody won in just 4 balls. So yeah, so I've simulated 100,000 boards in one program. And of course, somebody wins in just 4 balls. Yeah. Okay, everybody, I'll see you on Friday. I hope that your rest of your day is wonderful. And even your Thursday. I'll even go that far. I hope your Thursdays are wonderful too. Okay. All right. Bye, everybody.
Bye. Have a good day.
Have a good day, Professor. Thank you.
Thank you.
Take care.
Bye-bye.